Hello everyone. This video is related to the chapter of exponents and radicals. These questions have been taken from the College Panda SAT math book. In this video, we are going to cover all the 16 questions of the chapter 1 exponents and radicals from the College Panda SAT math book. So let's start the video. The question we have is that if a raised to the power of negative 1 over 2 is equal to 3, then what is the value of a? The options we have is negative 9, 1 over 9, 1 over 3, and a positive 9. So the crux to solve this question is that a raised to the power of negative n is equal to 1 over a raised to the power of positive n, where n belongs to any real number. So the given we have is that a raised to the power of negative 1 over 2 equal to 3. It implies from our above formula that we can write a raised to the power of negative 1 over 2 to be equal to 1 over a raised to the power of positive 1 over 2, which is equal to 3. Now squaring on both sides implies 1 squared over a raised to the power of 1 over 2 whole squared equal to 3 squared. Now it implies 1 squared 1, a raised to the power of 1 over 2 whole squared is a, 3 squared is 9, which further implies that a is equal to 1 over 9. So the correct option is the B option. The question we have is that if 2 raised to the power of x over 2 raised to the power of y is equal to 2 raised to the power of 3, then x must equal. The options we have are y plus 3, y minus 3, 3 minus y, and 3y. The crux to solve this question is to know that when the bases on both the sides, that is on the LHS as well as the RHS, are equal, then we can say that the exponents must equal. So we can write that m must equal to n. So if you know this concept, you can solve this question very easily. So now moving towards the solution, we can write the given information as 2 raised to the power of x over 2 raised to the power of y is equal to 2 raised to the power of 3. Multiplying 2 raised to the power of y on both the sides gives us 2 raised to the power of y times 2 raised to the power of x over 2 raised to the power of y is equal to 2 raised to the power of 3 times 2 raised to the power of y. Now we can cut 2 raised to the power of y and 2 raised to the power y in numerator and denominator on the LHS. So now we end up having 2 raised to the power of x equal to 2 raised to the power of 3 times 2 raised to the power of y. And we know that when the bases are the same, we can write the RHS to be equal to, simply we can add the exponents. So we can write 2 raised to the power of 3 plus y. So since the bases are equal, we can equate the exponents. So it implies that x equal to 3 plus y. So 3 plus y is same as y plus 3. So hence our correct option is the option A.
The question we have is that if y to the power of 5 is equal to 10, then what is the value of y to the power of 20? The options we have is 40, 400, 1000 and 10,000. The crux to solve this question is to know that when we multiply two numbers with the same base but with the different exponents, it becomes equal to a number with the same base and added exponents. So if you know this thing which I have put in the box, then this question is very easy for you to solve. So starting with the solution, the given information to us is that y raised to the power of 5 is equal to 10. We have to find the value of y raised to the power of 20. So y raised to the power of 20 is nothing but y raised to the power of 5 plus 5 plus 5 plus 5. We can write 20 as 5 plus 5 plus 5 plus 5. So we can distribute these 5s and make 4 different numbers with the same base, and in this case we have the exponents also the same. So we can write y to the power of 5 times y to the power of 5 times y to the power of 5 times y to the power of 5. So we know that y to the power of 5 is nothing but 10. So we can write y to the power of 20 to be equal to 10 times 10 times 10 times 10. So y to the power of 20 becomes 1, 2, 3, 4. So this is nothing but 10,000. Hence the correct option to this question is the option D.
The question we have is that the expression 4th root over x squared y raised to the power 4, where x is greater than 0 and y is greater than 0, is equivalent to which of the following? The options we have are root over xy, y times root over x, 1 over x squared, and x squared times y. So the crux to solve this question is to know that nth root of anything raised to the power of, let's say, m is equivalent to x raised to the power of m by n. So if you know the concept that I have put in this red box, then you can solve this question easily. So coming to the solution, the given expression we have is 4th root over x squared times y to the power of 4. This can be written as x squared y to the power of 4 whole raised to the power of 1 by 4. This can be written as, we can distribute this power to both x and y, and we can get x squared whole raised to the power of 1 by 4 times y raised to the power of 4 whole raised to the power of 1 by 4. Now multiplying the power of x with the power of x square, we can get x raised to the power of 2 times 1 over 4 times y. Similarly doing it for y, so we can multiply the power of y with the power of y to the power of 4. Now after simplifying, we can get x to the power of 2 by 4 times y to the power of 4 by 4. This can be written as x to the power of 1 over 2 times y to the power of 1. X to the power of 1 over 2 is nothing but root over x times y to the power of 1 is nothing but y. So the expression given in the question, that is 4th root of x squared y to the power of 4, is equivalent to y times root over x. Hence the correct option is the option B. The question we have is that if root over x cubed whole over 4th root of x is equal to x to the power of c for all positive values of x, then what is the value of c? The options we have are 3 over 2, 1 over 4, 5 over 4, and 7 over 4. So the crux to solve this question is to know that nth root of anything raised to the power of m can be written as x to the power of m over n. One more thing you should know is that when two numbers with similar base are multiplied with each other, then the exponents gets added up. One more concept you need to know is that 1 over x to the power of let's say t is equal to x to the power of negative of t. So these are the three concepts which you should know to solve this question. So the given we have is root over x cube over 4th root of x. So this can be written as x to the power of 3 over 2. This can be written as x to the power of 1 over 4. When we bring x to the power of 1 over 4 to the numerator, the sign gets changed, and then we can write this as x to the power of 3 over 2 times x to the power of negative 1 over 4. So since the bases are equal, we can add the exponents. So we can write this as x to the power of 3 over 2 plus negative of 1 over 4. So we know that plus and plus minus is minus. So we can write this as x to the power of 3 over 2 minus 1 over 4. 3 over 2 can be written as 6 over 4 minus 1 over 4. Since the denominator is same, we can solve this by subtracting 1 from 6, that is 6 minus 1 over 4. We get x to the power of 5 over 4. So in question we are given that this is equal to x to the power of c. Hence we can say that since the bases are same on both the sides, it means that the exponents must equal. So it implies that c should be equal to 5 over 4. So hence the correct option is C. The question we have is that if 3 raised to the power of x is equal to 10, then what is the value of 3 raised to the power of x minus 3? The options we have are 10 over 3, 10 over 9, 10 over 27, 27 over 10. So the crux to solve this question is to know that anything raised to the power of a plus b can be written as x to the power of a times x to the power of b. One more thing you should know is that x to the power of a is equal to 1 over to the power of negative of a, and similarly x to the power of negative of a is equal to 1 over x to the power of positive of a. So the given we have is that 3 to the power of x is equal to 10. We have to find the value of 3 to the power of x negative 3. So we can distribute the exponents. We can get 3 to the power of x times 3 to the power of negative 3. Now 3 to the power of negative 3 can be written as 1 over 3 to the power of positive 3. This can be written as 3 to the power of x over 3 to the power of 3. Now since we are given in the question that 3 to the power of x is equal to 10, so we can substitute it. We can get 10 over 3 to the power of 3. So 3 to the power of 3 is equal to 3 times 3 times 3. 3 times 3 is 9, and 9 and 3 is 27. So 3 to the power of 3 is 27. So we can get the value of 3 to the power of x minus 3 as 10 over 27, 27. Hence 3 to the power of x minus 3 is equal to 10 over 27. Hence the correct option is option C. So the question we have is that if a and b are positive even integers, then which of the following is greatest? The options we have are negative 2a whole raised to the power of b, negative 2a whole raised to the power of 2b, 2a whole raised to the power of b, and 2 times a raised to the power of 2b. So to solve this question, we have to compare each of the option with other. So we can write the options first, A, B, C and D. A option is negative 2a raised to the power of b, negative 2a raised to the power of 2b, 2 times of a raised to the power of b, 2 times a raised to the power of 2b. Now, since we know that b is always a positive even integer, so it implies that anything raised to the power of b, whether the base is positive or whether the base is negative, anything raised to the power of b will be positive because b is a positive even integers. So negative 2a whole raised to the power of b can be written as 2a raised to the power of b. This can be written as 2a whole raised to the power of 2b. Now keeping c and d as it is, 2 times a raised to the power of 2b. So opening the brackets, we can get 2 raised to the power of b times a raised to the power of b, 2 raised to the power of 2b times a raised to the power of 2b, 2 raised to the power of b times a raised to the power of b, and 2 raised to the power of 1 times a raised to the power of 2b. Now we have to compare these 4 numbers and we have to find which of them will be greatest. So to find which one of them is greatest, we need to compare them. So first we can compare the a and its powers. So we can see that 2b will always be greater than b, right? So we can say that a raised to the power of 2b will always be greater than a raised to the power of b. So we can say that b and d will always be greater than c and a. So c and a will not be the greatest numbers, so hence we can eliminate them. Now we are left with b and d. We have to compare these two options. We can compare from the powers of a, since we can see that powers of a are equal in both the options. So we can move to the powers of 2. Since we know that b is a positive even integer, so the minimum value of b is 2. So the minimum value here of 2b will be 4. So we can see that 2 raised to the power of 2b will always be greater than 2 raised to the power of 1. Since these a raised to the power of 2b is common in both the options, but 2 raised to the power of 2b is greater than 2 raised to the power of 1. So we can say that d will not be the greatest one, and hence we can say that b option will be the greatest one. So hence the correct option is B. The question we have is that if x square equal to y cube, then for what value of z does x raised to power 3z is equal to y raised to the power of 9? So the options we have are -1, 0, 1 and 2. So we have to find the value of z. So moving to the solution, the given information we have is that x square is equal to y cube. We are also given that x raised to power 3z is equal to y raised to the power of 9. We can write y raised to the power of 9 as y raised to the power 3 plus 3 plus 3. Now if you know one concept that anything raised to the power of a plus b, in this case anything is u, is equal to anything raised to the power of a times anything raised to the power of b. So we can write this as y raised to the power of 3 times y raised to the power of 3 times y raised to the power of 3. We are given that y raised to the power 3 is equal to x squared. So we can write x squared times x squared times x squared. So now we also know that u raised to the power of a, that is anything raised to the power of a, times anything raised to the power of b can be written as anything raised to the power of a plus b. So in this case we can write this x squared times x squared times x squared as x raised to the power of 2 plus 2 plus 2. So from here we can write x to the power of 3z becomes x to the power of 6. Since the bases are equal on both the sides, it implies that the exponents must also equal. So from here it implies that 3 times z is equal to 6. So it implies that z is equal to 6 by 3, that is equal to 2. So our answer is 2. So the correct option is D. The question we have is that if root over x times root over x is equal to x to the power of a, then what is the value of a? The options we have are 1 over 2, 3 over 4, 1 and 4 over 3. So the crux to solve this question is to know that root over x can be written as x raised to the power of 1 over 2, and also you should know that x raised to the power of a times x raised to the power of b can be written as x raised to the power of a plus b. So we are given that root over x times root over x is equal to x to the power of a. So in the next step we can write root over x as x to the power of 1 over 2. Since the power of x here is not indicated, it implies that the power is 1. So we can write the expression inside the square root as, so this is equal to x to the power of a. We can write this as root over x to the power of 1 plus 1 by 2, that is equal to x to the power of a. So in the next step we can add these two. So after adding we can get root over x to the power of 3 over 2 equal to x to the power of a. So now we can write this expression as x raised to the power of 3 over 2 over 2 is equal to x to the power of a. In the next step we can write this as x raised to the power of 3 over 2 times 1 over 2, that is equal to x to the power of a. Now in the final step we can calculate the value of this expression here. 3 by 2 times 1 over 2. So x raised to the power of 3 times 1 is 3, 2 times 2 is 4. So x raised to the power of 3 over 4 is equal to x raised to the power of a. Since the bases on both the sides are equal and the numbers are also equal to each other, it implies that the exponents also must equal to each other. It implies that 3 by 4 is equal to a. So hence the correct option is option B. So the question we have is that if x raised to the power of AC times x raised to the power of BC is equal to x raised to the power of 30, where x is greater than 1 and a plus b is equal to 5, then what is the value of C? The options we have are 3, 5, 6 and 10. So moving on to the solution, we are given that x raised to the power of AC times x raised to the power of BC is equal to x raised to the power of 30. We know that x raised to the power of a times x raised to the power of b can be written as x raised to the power of a plus b. So applying this concept in this question, we can get x raised to the power of AC plus BC equal to x raised to the power of 30. Now we know that when LHS and RHS are both equal to each other and the bases are also equal, it implies that the exponents also must equal to each other. Now it implies that AC plus BC should be equal to 30. Now we can see that C is common in both the terms. So we can take out C and we can write C times A plus B equal to 30. Now since we know that A plus B is equal to 5, which is given in the question itself, we can write C times 5 equal to 30. Now dividing 5 on both the sides, we can get C equal to 30 over 5. Now 30 over 5 is equal to 5 times 6 is 30. So 30 over 5 is 6. Hence C is equal to 6. And the correct option is option C. The question we have is that if 4 raised to the power of 2n plus 3 is equal to 8 raised to the power of n plus 5, then what is the value of n? The options we have are 6, 7, 8 and 9. So the crux to solve this question is to know that anything raised to the power of a whole raised to the power of b is equal to anything raised to the power of a times b. The given information we have in the question is 4 raised to the power of 2n plus 3 is equal to 8 raised to the power of n plus 5. And we know that 4 is equal to 2 times 2, that is equal to 2 squared. And 8 is equal to 2 times 2 times 2, that is equal to 2 raised to the power of 3. So writing 4 as 2 raised to the power of 2, now whole raised to the power of 2n plus 3, writing 8 as 2 raised to the power of 3, whole raised to the power of n plus 5. Now applying the concept we discussed initially, we can get 2 raised to the power of 2 times 2n plus 3 equal to 2 raised to the power of 3 times n plus 5. Now since the bases are equal, we know that the exponents also must equal. So 2 times 2n plus 3 is equal to 3 times n plus 5. Now opening the brackets, we can get 2 times 2n is 4n plus 2 times 3 is 6 equal to 3 times n is 3n plus 3 times 5 is 15. Now subtracting 3n from both the sides, we can get 4n minus 3n as n plus 6. 3n minus 3n is 0. Now we are left with 15 on the RHS. Now subtracting 6 from both the sides, we can get n plus 6 minus 6 is 0. So we are left with n on the left hand side, which will be equal to 15 minus 6. 15 minus 6 is 9. So hence the correct value of n should be equal to 9. Hence the correct option is option D. The question we have is that which of the following is equivalent to minus 2 raised to the power of 5 over 3. So the options we have are minus 2 times cube root of 4. Option B is 2 times cube root of 4. C is minus 4 times cube root of 2. And option D is 4 times cube root of 2. The crux to solve this question is to know that x raised to the power of a by b can be written as bth root of x to the power of a. We have to find the value of minus 2 raised to the power of 5 over 3. So we can write this as cube root of minus 2 raised to the power of 5. So we can write this as cube root of minus 2 times minus 2 times minus 2 times minus 2 times minus 2. That is multiplying minus 2 5 times. So since we know that this is a cube root, so if we have three similar digits multiplied with each other, we can take that particular digit out of the cube root. So we know that these minus 2 are same, so we can collect these three minus 2's and we can take it out of the cube root. So we can write this as minus 2 times cube root of minus 2 times minus 2. Now rewriting the expression we are given in the question, we can write this expression as minus 2 times cube root of minus 2 times minus 2. Now we know that minus 2 times minus 2 is positive of 4 because minus minus is plus. So minus 2 times cube root of 4. So we can write this as minus 2 times cube root of 4. And this option is matching with option A. Hence the correct option is option A. The question we have is that if 2 raised to the power of x plus 3 minus 2 raised to the power of x is equal to k times 2 raised to the power of x, then what is the value of k? The options we have are 3, 5, 7 and 8. So moving on to the solution, writing the given information as it is, 2 raised to the power x plus 3 minus 2 raised to the power of x is equal to k times 2 raised to the power of x. Since we know that anything raised to the power of a plus b can be written as x raised to the power of a times x raised to the power of b, we can write this the expression 2 raised to the power x plus 3 as 2 raised to the power of x times 2 raised to the power of 3 minus 2 raised to the power of x is equal to k times 2 raised to the power of x. We can take 2 raised to the power of x common on the LHS, so taking it out, so we can get 2 raised to the power of 3 minus 1 is equal to k times 2 raised to the power of x. Since 2 raised to the power of x is common on both the sides, we can cancel it. It implies that 2 cube minus 1 is equal to k. Now 2 cube is 2 times 2 times 2. 2 2s are 4, 4 2s are 8. So 2 cube is 8. So 8 minus 1 is equal to k. It implies that 8 minus 1 is 7. So 7 should be equal to k. Hence the correct option is option C. The question we have is that 5 cube raised to the power of 4k is equal to 5 raised to the power of 1 over 3 whole raised to the power of 24. Then what is the value of k? The options we have are minus 6, 2 over 3, 3 over 4 and 2. So the crux to solve this question is to know that anything raised to the power of a whole raised to the power of b can be written as anything raised to the power of a times b. So the given we have is 5 cube raised to the power of 4k is equal to 5 raised to the power of 1 over 3 whole raised to the power of 24. Now applying the concept we learned initially in this expression, we can get 5 raised to the power of 3 times 4k is equal to 5 raised to the power of 1 over 3 times 24. Now since we know that the bases are equal on LHS and RHS, that is left hand side and right hand side, it implies that the exponents must equal. So we can write 3 times 4k equal to 1 over 3 times 24. So 3 times 4k is 12k, and we know that 3 times 8 is 24, so we can write 3 times 8 is 24, so we can write 12k is equal to 8. So dividing 12 on both the sides, we can get k is equal to 8 by 12. So 4 is common to both, that is common to 8 and 12. So we can write 8 as 4 times 2 and 12 as 4 times 3. So we can cut 4 from the numerator and denominator. So we can get k is equal to 2 by 3. Hence the correct option is option B. The question we have is that which of the following is equivalent to x raised to the power of 2a over b for all positive values of x where a and b are positive integers. The options we have are bth root of ax square, bth root of x raised to the power 2a, bth root of x raised to the power of a plus 2, 2a root of x raised to the power of b. So the crux to solve this question is to know that nth root of anything raised to the power of m can be written as x raised to the power of m over n. So these type of questions are lengthier because in this type of questions we have to check each of the options and we have to match it with our expression given in the question. So I would advise you to attempt this type of questions in the very last, because this type of questions take a bit longer time than the other ones. Because in this question we have to check all the options. So we have to check option A first. Option A is b root of ax square. So you can write this as ax squared whole raised to the power of 1 over b. That can be written as a raised to the power of 1 over b times x raised to the power of 2 over b. Now since it is not matching with the expression given in our question, we can say that this is not the correct answer. Similarly, doing for the B option, bth root of x raised to the power of 2a is equal to x raised to the power of 2a over b. Now since this matches with the expression given in our question, this expression, we can say that this is the correct option. Now since we know that B is our correct option, we don't need to check option C and option D. But for your convenience, I will do it for you. Option C is x raised to the power of a plus 2, which is equal to x raised to the power of a plus 2 over b. Now this also doesn't match with our expression. Option D is 2a root over x raised to the power of b. This can be equal to x times raised to the power of b over 2. And since our expression doesn't matches with this also, we can say that this won't be the correct option. Hence the correct option is option B. The question we have is that if x squared y cube is equal to 10 and x cube y square is equal to 8, then what is the value of x power 5 times y power 5? The options we have are 18, 20, 40 and 80. So the crux to solve this question is to know that anything raised to the power of a plus b is equal to anything raised to the power of a times anything raised to the power of b. We have to find the value of x power 5 times y power 5. Now we can write these x power 5 and y power 5 such that we can get these terms out of it. Since 5 can be written as 2 plus 3, we can write that. So x power 2 plus 3 y power 2 plus 3. Now we can distribute the powers and we can apply these concepts which we learned initially, and we can write x power 2 times x power 3 times y power 2 times y power 3. Since we know the value of x power 2 times y power 3 and x power 3 times y power 2, we can bring them together with each other and we can write this as x square times y cube from here, times x cube from here, times y square from here. Now we can write x power 5 times y power 5 equal to x power 2 times y power 3 times x power 3 times y power 2. Since we know that x power 2 times y power 3 is equal to 10, which is given in the question itself, we can write this as 10 times x power 3 times y power 2. X power 3 times y power 2 is 8. We can write here as 8. Now we know that 10 times 8 is 80. Hence, x power 5 times y power 5 is equal to 80. Hence, the correct option is option D. Thank you for watching. I will see you in the next video.